and what's your
Definitely, I would like to say that I was actually
responsibilities in the
responsible for
project
working as a data
study
science
practice?
engineer with the
Okay,
Bank of America in the
definitely. What
Dallas,
I would like to
Texas,
say,
and I was
I
actually
have
responsible for building
8
these
years of experience
statistical
in the machine
models
learning.
using the
I started
Bayesian,
my career from
HHM,
the Stable
and the
ICT
machine learning
on
classification
2010.
models like the XGBoost,
I have
and
so
highly
when I was
immersive data
starting
science
there,
program
it's
involving
not
the
that
data
much
manipulation and visualization,
big problem
and developing
I
the
solve, I
prediction
should
model
say.
for the crop yield, and
There
using
was
the
kind
feature
of a
engineering
highly
for the
move on the
exploratory
data
data
processing, data
analysis and doing
cleaning,
data
and
manipulation and data
applying
preparation and
very
normalization to the predictive modeling,
kind of
and improving
classical
the efficiency
machine
and
learning
accuracy
algorithms,
by
right?
evaluating the model in the
And then
Python
I
and
went to the
R.
state fam. I got
This project was
better
focused on the customer
opportunity
segmentation
to learn
based on the
about
machine learning and
machine learning.
statistical
Then I realized that
modeling
I
and
really
effort,
understand
including the
the
predictive
mathematics
analysis
behind this,
of the
and I
application.
need
I
to
was
have
also
some
training the
statistical
deep
model
neural network
understanding
with
and
petabyte
math
scale
behind those kind of
cluster data, which was actually
stuff,
used in
right?
this
So let's
case,
say
and
you
we were
are
also
using a
responsible for
database.
doing some of the
Behind those, you have a lot of
work
mathematics.
on top of
Like even
the
when you are doing the
large scale
clustering,
data sets and doing the
clustering,
improvement of the model
you
using the
have to
SciPy
import
and the
SQL
NumPy as
alpha,
well as the
SQL alpha.
Pandas
You have a
and the
kind of
Keras
math science
library,
behind this,
and
and
working on the
also you are
algorithms like
applying
the
the decision
logistic
tree, but
regression as well as the
so many
decision tree and the
um, um,
naive Bayes,
like
and
internal
developing a
calculations, so
pricing model for the
mathematics
various
going on.
products and
And
services bundled,
so I
offering to
realized, okay,
optimize
let
and
me do
predict
some
the
applied
gross
math that
margin,
works
and built
based on
the
the data
price
science. And
elasticity
I was
model for
looking
the various
actually for the
products
data
and
science.
services bundled,
I
offering
got
under
the
the
opportunity. I
supervision of
got
the
the
senior
offer
data
from
scientist,
University of
perform the
Houston,
data
which is
transformation
one of the
method
Taiwan
for
university
rescaling and normalizing the
campus,
variables, and
and
worked on
they
the data
usually
architects and IT
providing.
architects and predictive
They were
causal
providing
model
like
and the
a
machine
applied
learning
mathematics
model for the
concentration and
allocation
data
planning
science,
as well as
right?
the
And
Hadoop
then
architecture using the
besides of those,
HDFS and the job tracker, and using the
then after
Spark
I
and the
completed my
Scala
PhD,
as well as the
I joined to
Kafka
the
for the
Bank of
Spark
America as a machine learning
streaming, I would like
engineer
to say
and
in
data
this
scientist,
case, which was actually used, I
where
would like to say,
I
on the
would
multiple kinds
communicate.
of
I would be
environments
using
in
mostly
the
the
real
those
time
kind of
servers
machine learning
on
algorithms.
the
So I would say define myself to be this kind of algorithm to be the traditional one because um, that there are new features like deep learning, natural language processing. Even though I've been involving on the natural language processing for some kind of problems, but there are a lot of stuff going on, like Erica Shard development team. There, I'm not on that side also. But what I've been doing in the machine learning, I've been applying some supervised learning, some unsupervised machine learning algorithms in the Bank of America. That's the summary of what I have.
Okay. So, how much is your total experience you have?
8 years of experience.
And out of 8 years, how much experience is in data science and
so
machine
basically,
learning?
I think all of
Basically,
that
I
is on the
started
data science because I was
back
actually
in
working on
there.
the
Also, I was
data
working as
science
a
from
data
the day
analyst
one.
back into my country, right? So, what I would say, mostly here, when I started here, I started in the data science process, like as a data scientist, yeah. Cleaning data, everything like a EDA, data exploratory data analytics, and visualization, those kind of stuff at the beginning, and then that's how I started my career.
Okay. Okay. So, what's the project you are currently doing, right?
So
What type
currently
of
in the
role
Bank of
in
America,
that
I'm working
project,
as a
right?
Okay. Bank of
engineer for the big
America,
data
like
analysis
I
of the
was working on the
application,
first project
and
that
on the
I
various
started
kinds
with. It
of
was the
stuff, I would like to say
fraud
in this case
detection,
for
right?
the predictive
Fraud
causal
detection
modeling as well
was
as the
the
task
problem that I
tracker and the data node.
encountered.
And I would
I have a
like to say I was
problem with
also
family members.
responsible for working on the backward
I'm
and the
sorry.
forward
Um,
propagation in the
I started with the fraud detection problem,
neural network
where
which
I
I was
have to
actually
apply
working
the
on and using the machine
logistic
learning and
relevance
data science
and the
algorithms and
decision tree.
integrating into the
We
production
also
system for
applied the
different
random
business
forest,
needs,
but
and working on the
based
multiple
on the
data set and
accuracy and the
containing 2
complexity
billion
that I
values which are
encountered,
structured and
I
unstructured
figured
data,
out that okay,
and
decision
using
tree
the
would
Amazon
be
Redshift platform for the
better
data
because there
cleaning
was
and process
no
applied in the
much
backward and
difference in the
forward.
accuracy, but the complexity was much higher. Because we are trying to remove the overfitting problem on the decision tree. We are trying to see if there is an overfitting problem. But there wasn't, like we decided after that if the decision tree was the one of the model that we chose for the fraud
Mhm.
detections.
Mhm.
Another problem
So,
we did, yes, go ahead.
yeah, I just want to know that you told me that you choose the decision trees over logistic regression, right?
Right.
So you told me the reason, right? It's related to overfitting, right?
No,
So
I mean logistic regression was the accuracy percentage was a little less. So the
So
when we
basically, in
apply
this
the
case, we were
logistic
actually using
regression, the
multiple data
accuracy
sets
percentage was
containing
a
2
little
billion
less.
values,
So
which are having the
overfitting
structured
problem
as well as
in
the
the
unstructured
decision
data.
tree. So
And then
we
inside
try to
that,
apply it for the
we were
random
actually
forest
going ahead
instead
and,
of
trying to apply
decision tree.
the
That's what
Amazon
I was saying.
Redshift
I'm
platform on
sorry
top of
if
that,
there
and
was
going ahead and,
misunderstanding.
working on some of
okay, just tell
the
me
various
what is
kinds of things
logistic
inside that,
regression
which was
and what
actually
is
helping
in
us and
logistic
trying
regression.
to
What
build
is
the
maximum likelihood
logistic relationship
estimation?
with that, I would like to
What
say.
you do, like in the logistic regression, basically,
And then we were trying to,
you classify
get
the
the
binary
logistic regression
outcomes.
for
Like
the
let's say
application and
whether the
trying to,
particular transaction is
make
fraud
sure
or
that
not,
the
right?
regression
So
really
we
helps
are
us in
trying
the
to
various kinds
figure
of
out
stuff, and
this
trying
transaction was
to,
something you
work
have
on
a, I
the
would say there was
integration of the
a bad
application
persistent
related
data that we had,
logistic
and we have to
regression,
apply.
I would
We
like
have
to
to
say,
check
and
whether
try
that
to do
particular
it
transaction is a
and
fraud
work
or
on
not.
top of that so
So
that
we
we
use
can, make sure and try to
like a sequence
release
function
this in terms of
to
the
use to
real-time servers, and then finally going ahead and,
classify those
putting it on
like the
target environments, I would
classification
like to say.
boundary, and we use the cross entropy function to calculate the cost function and
We will be also
figure
trying to
out
do some
whether
of
the
the
particular
allocation planning
transaction
and
is
the
fraud or
deployment
not.
planning in this case.
So what is maximum likelihood estimation in that?
Like in the maximum likelihood
So
estimation,
basically, in the maximum
this is the
likelihood
probability that
estimation, I
is
would like
crossed
to
in
say
time. Like
that
the maximum likelihood
uh,
estimation is
it is
I would say like
something which will
this is the
actually let you do the
probability
various
in
kinds of
your
stuff inside that,
normal curve.
like the
Let's say
method
you
of the
have a
estimation
curve,
of the
right,
parameters of
and
the
then per
statistical
particular point
model,
you have a
so that the
probability
observed data is most
accumulated
probable.
in
Specifically,
the
this is done
maximum
by
likelihood
finding out the
estimator.
value of the
So
parameter,
how to
and
calculate the
in the
probability in the
statistics,
maximum
the
likelihood function?
maximizes the likelihood of the
When
function,
you
which is
calculate
joint probability of the observed data
maximum
over
likelihood,
the
like in
parameter
statistics,
space,
like
and that maximizes the
join the
likelihood
probability
function
and
called the
for
maximum
the
likelihood
joint
estimate.
probability and
And the
observation
logic of the maximum
going
likelihood
over
is
the
both
parameter
intuitive
space,
and
and then
flexible, and
maximize
as
the likelihood
such
function
is a
called
measure
the
of the height
maximum
of every
likelihood estimate.
penguin in a
So the logic
population,
of
and
the
that is how it
maximum
will actually
likelihood is
work.
like both rigid and flexible, and then that's what I would say, like the measure of the height of that you can compute over in the curve.
Okay, so okay, do one thing.
Yes.
Actually, I just share my screen.
Okay.
Screen. Okay. Are you able to see my screen?
Yes.
So just write the code, right? Just write the basic steps how you will start the particular machine learning model, right? So how you will create the model, right? What are the steps comes in that, right? From starting gathering the data, you suppose you are gathering the data from the Excel, right?
Right.
Right. So in that case, what API you will use, what types of libraries you will use, right? Then after that, use the whole process steps, right? Just like a feature engineering and exploratory data analysis, right? And model creation. So all those steps, just write it and write the library function also, right?
Okay.
So write it down here.
Okay. Let me try to write it down. It's not writing.
That's not writing.
It's not writing at all. No.
Okay, do one thing. You just share your screen, right?
Okay.
Okay, just share your screen and open the notebook, right?
Okay.
Right, and write the function.
Can you see me now? See, I share the screen.
No.
Can you see my screen?
No.
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 I share the screen. It says green. It says there is a share thing. I don't know.
No, it's not showing.
I saw that your screen before, but not now. You here is the showing is the share. Like it says sharing and the recording is going on. That's what it shows me here. I don't know.
No, it's not showing. Okay. So just tell me about the difference between bias and variance. What is the bias? What is the variance?
Bias is a kind of what I would say like it's a noise that you have
So
in your
basically, I would
database
like to
or
say that in the machine
where you have a
learning, the
measure like
bias
or the variance is
is
how
something
good
which is
your
available there, and then the trade-off. So the goal of
the
any
data is derived
supervised
from
machine
your
learning algorithm is to
mean.
achieve
That's
the
what
low bias and
the
low
variance
variance.
is.
And the parametric or linear machine learning
No, in
algorithms have
terms of
often
machine
high
learning,
bias
if
but
I
low variance.
provide you the data,
Non-parametric or
right?
non-linear machine
So
learning
how you
algorithms
can
often have a low
identify
bias
that
but a
is
high variance,
that
and that is how it will
particular
actually be working in this case, I would
model is
like to say.
showing a high bias or high variance
Oh,
or low
okay.
bias?
So, yeah. In terms of machine learning, I would say like the bias is something which is available there, and then there is a trade-off goal, like for the supervised machine learning algorithm to achieve a low bias, right? So the variance is a parametric rolling thing. So so like what you
And then we
see
have
like
the
for
parametric and non-parametric
machine
linear
learning algorithm, you have the like a
rolling
low
thing in
bias
this case, which will be
or the
actually
high
used.
variance you want to control over them. So it should be working in this case. So I would like to say like have a parametric and non-parametric linear rolling in this sense, I would say.
Can you please just elaborate more?
Yeah, in this
Definitely, I would
case,
like to
what you
say
do
that
in the
the
bias, I would like to
parametric
say
or linear machine
your
learning algorithms often have a higher bias.
so
And I
like
would like to say
there is
that
a
coming to the
parametric in
bias
the
and the
machine learning
variance
algorithm
trade-off, there are
where the
various
higher
kinds
the
of things
bias,
inside
and
that. So bias is the difference
I
between
would
the
like to
average
see
prediction
like
of
coming
our
to
model
the
and the
bias
correct
and
value which
variance
we are trying to
trade-off,
predict.
right?
And the model
And
with
then
high bias pays very little
But
attention to
my
the training
question
data
is
and
how you
oversimplifies the
will
model.
quantify
It
that
always
whether
leads
it's
to the
high
high
bias or
error
high
on
variance.
training and testing of the
So
data, and the
what are
variance
the
is the
steps?
variability of the
So
model prediction for a
understand,
given
right?
data
You have a
point or
model,
value,
right?
which
So
tells us
you
the
have the
spread of the
feedback.
data. So the
So how
model
you
with
will
high variance
identify
pays a lot
that
of
this
attention
model
to
is
the
going to
training
high
data and
bias
does
or
not
side or it's going to
generalize on
the
the
high
data which
variance
it has
side?
seen before.
right.
As a result,
So
such models
what
perform
I
very
would
well on
do
the
like
training data but has
in the
higher
to find out
error rates in
the
the
high
real-time
bias
data, I
in
would like
things
to say
like
in this
in the
case.
machine learning, if there is a the gradient functions when you are your cost function is like going up like that would be saying like the bias is there, the higher the bias is the bias is too slow. I think it's a convergence like too slow or something like this.
Um, okay, just tell me that what is the gradient function? You told me, gradient functions basically tells the high bias and the high variance and low bias, low variance.
Right.
What is the gradient? What do you understand from the gradient?
Like the gradient is a kind of
So
the
basically, I would like
variance,
to say
like
that the gradient is
as
something
you
which
said
will
it,
actually
like
help you to
that's
do
what
that. I would like to say in this case, so the gradient descent is an optimization
I have to
algorithm
say in
used
this
to
case,
minimize
like a
some
gradient.
function by
The gradient
iteratively
descent
moving
is
in the
like
direct
it's the
of the
optimization
steepest
algorithm. I
descent
have
by
to say
using
it's a
the
gradient descent
function in this
algorithm. Like
case, I would like to say, and then
How
the
you will
gradient will actually
optimize
help you to
that? So
define the
how the
calculation of
you
the
taken
loss
the
curve at the
derivative?
starting point.
Firstly, what you have like if you have to let's say let's talk about the linear regressions. Like then you have a MSE, right? That's the cost functions. You have the predicted minus the actual one that's squared, and you take the derivative of those, and then you want to optimize those parameter, the slope, and then the y-intercept, the m values, and then b values, and updating those parameter. You want to get the
So
optimum,
basically,
and
coming to
that's
the gradient, we are actually
minimizing
having
your
the iterative approach diagram,
maximum
and we will be having the time and computing
mini
resources to
square error
calculate the loss
thing.
for all the possibility values of the
So
kind of the problems in this case.
my question is, right, the thing is that suppose you have a gradient, right?
Right.
And you are creating a model, right?
Right.
So when you have creating a model, right?
Right.
Right. So how the gradient is understand, right? we have to go increase the weight or decrease the weight, right? So
Right.
how he basically understand?
Like you have this is a gradient, like you have a slope like this, right? If you have a curve like this, and then you have a gradient, and that will tell you
So
which direction
basically,
you have to go.
coming to the gradient descent,
Because
it is an
it's
iterative
based on the
method to
gradient
improve a
you
given
have
set of weights. We will try to get the
um,
sense of the value of the
which way
cost
you have
function.
to go.
So machine learning
Because
models
it,
predict
Which
the
method? Yeah,
parameters
how
based
he
on that, and then I would like to
how
say have a
gradient
cost
descent
function to
understand
have the
we
evaluation
have
of
to
how
go
the
this
particular
side
set
or
of
this side.
parameters are. Many
So just
machine learning algorithms are
how
reduced to
it
the finding of the
basically
set of
find the
weights
optimal point.
for the
Right.
model,
I mean,
which
the gradient,
maximizes the cost function. In this case, for
gradient is a
example, if the
method to
prediction is
to
p, the
find out
target
which way
is
do you
t,
go.
and our
You
error
go to the
metric is a
up to the curve
squared
or
error, then the
to
cost
the
function is
other side. That's
jwp
what
hyphen t square. Now that the
gradient
predicted
will
value depends on the
give you the
input x
idea.
as well as the machine learning model.
How he identified that up to the high or the low to the high?
Um, so
From high.
you have the gradient, right? So the gradient, that's a slope. It's based on the slope. Like you have a positive slope
Now
and
coming to
negative
the
slope.
slope, I would like to
Like
say that the
like
pseudocode is
this
the
is a
descent and the
tangent to the
gradient,
curve you have,
and
right?
we have the
And
intuition for the
then
gradient
based on
descent, and
those,
then
that
one
will
of
tell you
the
whether this is going
simplest
upward and
strategy you can use
this
is to
is the
feel the ground
slope
in
thing.
every direction
On
and do
which
that by
scenario to
using
basically
batch
go
gradient
to the
descent and
positive
variance of the
side or
gradient descent
negative
in this
side?
If
case.
you have a slope
And then
upward,
we'll
you
be
can
having
go
choosing
to
the
the
learning rate in this case,
upward,
which will
and
be
then you
actually
choose the
helping
negative
me
slope, like when
in
you go
the
to the
various kinds
downside
of
of the
things I would like to
thing.
say, and the learning of the rare
Uh-huh.
So in
several
that
methods.
case, so this we have a positive slope,
Right.
right?
Uh-huh.
So what gradient descent will do in that case? Or if we have a negative slope, so in that case, what we will do?
So if we
This
have
is
a
what
slope,
you
typically the
basically
value of
use
the
in this
learning
case.
rate
I
is
will say
chosen
this is
manually. We will
you use
usually
the
start
stochastic gradient
with a
descent
small value
because
such as
it has
0.1 and
a
adapt it to
problem
whether
of
the cost function
stopping
is
in the
reducing very
local
slowly
minimum
or
to
is
moving to the global
exploding,
minimum.
being erratic, and although the
I
manual
would say
choosing a learning
you
rate
will
is
go
still the
for
most common practice,
stochastic gradient descent.
several methods such as the Adam
I'm
optimizer
talking
as well as
about
the
the
RMS
simple
prop
gradient
have been
descent, not
proposed
asking about
to
the
automatically
coping,
choose a suitable
stochastic
learning
like
rate, and
that,
then apart from that, we
Okay.
will
I'm
also have
asking
the
about
pseudocode for
the
the
normal
calculation of the
gradient
gradients. So
descent.
the cost function
How you
with respect
identify
to the
that is
partial
the
differential
particular
of that, I
slope
would
is
like to say.
positive or maybe particular slope is negative. So how you will reach to the optimal point?
Yeah, of course. I mean, you have a derivative, right? So once you have a derivative, you plug in the points, and then at that point, you will check whether that particular value is a positive or negative, I think.
So what basically derivative do? What basically derivative do if the slope is positive side?
So basically,
Like
if the slope is
the
a
function is
positive
increasing.
side, we
Like
have
if
to
the
kind of
derivative
get
is
it
positive, the function is
fixed
increasing.
in
So
this
you
case.
have
So
to
we'll have to
say that
kind of
the
do some
function
of
is going
the
up in this
work on
case.
top of
If the
that to
derivative is
try to,
negative, the function is
make it
going
done in this
decreasing.
case so
So
that we
the
can
function
actually
will
have
go
this.
down in that.
How the function is increased, right? How the particular function is increasing on a positive side or
So
maybe
basically, in this case, the predictive value
Like
depends on
you
the
have a
input,
range of the
and
interval,
then
right?
we have
Like
the
you have
range
the
of the
points on the
gradients and the
data
update
point,
of the weights by
and then
amount of
based on that
promotion,
particular
and
point,
then
like
we'll repeat the cost,
on
which
that,
stops reducing this, and there is
you
some
try to
predefined
figure out
termination
those, and then
criteria which will be
you
there
would
in this case,
see like
and that will
whether
actually
you
be used
have
for the
a positive
validation
derivative or
of the
negative
data set, I
derivative
would
of
like
that.
to say.
Okay. Just tell me that how many types of gradient descent you have used in project?
Yeah,
That's a
so
several
basically
kind of
coming to the types of the
gradient descent and
gradient descent, I have been using the batch gradient
stochastic
descent, and
gradient
then apart
descent
from that, I
was
was also responsible
I
for using
used
the
like
other gradient
batch
descents, which
gradient
will be
descent,
actually used
and
in this
then
case for the small and the large
another
data
one
types. I have
is
also used the mini batch
was
and
a
the
stochastic
stochastic
gradient descent,
gradient,
I
and then
think.
the batch gradient, and then I
Okay,
have been using all of the
you
three in
use
my projects,
the
I would like to say in this
stochastic
case.
and batch gradient descent, right?
Batch, yeah.
So out of these two, which one is the best gradient descent?
I would rate
I
myself
would
to be
say
the
that I have
stochastic
actually
gradient
used
descent
the
because in the
stochastic one because that
stochastic
is the one
gradient
which has
descent
got
it
the
has
best performance in this
less
case.
chances of
And then
stopping in the
this type of
local
gradient descent
minimum
processes
points
one
or
training example as per the iteration, and hence the parameters are being updated even after
But
one
which one
iteration
is
in
the
which we
best
have only single example
to reach the
which is
optimal
processed, and then we have
point?
the mini batch gradient
it's
descent, which is the type of
to
gradient
reach
descent which
it's a little
works
bit
faster
complicated in the
than
stochastic,
both
but
the batch gradient and
to
the
go to
descent stochastic
the
gradient
fastest,
descent
if
in
you
this
are
case,
saying
I would
on
like to
that, I
say,
will be
and
batch would
then
be
it will be processed in the batches
the
of.
faster.
That
Mm-hmm.
is the faster.
Yeah, but the stochastic gradient descent find out the better approximations. I mean, better finding the best. I think for the best things, like for the fastest, like you would choose like a best. I think.
Are you sure that is the fastest?
So I
Because
think the
the batch,
stochastic is the one which is the
what I would
fastest in this
say, like
case, which would be really working out on
it's a
the
practice
multiple servers.
in
And then
the
apart from that, you also have the
when
algorithm
there
for the
are
stochastic
like
gradient descent in this
multiple
case, which is going to be used, and
things
that is
like
one of
you
the things
apply
which will
on
be
those,
making
and
it the
this would be
number one allocation
stochastic gradient
gradient
distribution
for
is
the
definitely
gradient
the
descent
better,
in this case.
I can say,
And
but
then we will try to make sure that the labels are actually properly
Stochastic is
done, and then
better or batch
we'll try to
gradient
take the
descent?
stochastic and try to proceed
stochastic would
with
be
that.
better in the sense.
How is it better? How is it better?
Like I said, it helps you to reach into the global minimum because it avoids the
That also goes to the global minimum.
which one? Yeah, it does. But what you have when you optimize this, I think. Let me try to remember what it does, because there was a theory that I learned into the degree when I was doing this, complete behind the theory, but
The thing is that you have used in your current project, right? So you know that, right? Which basically gives the best result. Because Bank of America is a financial bank and there is a lots of huge of data, right? The project which you are doing right now, right?
right,
Right? It's a financial area. So
right.
you know that which one is the best, right? So that's why I'm asking. You use the stochastic and batch using the sense.
Uh-huh.
So which scenario is the batch is best and
So
which
basically, I
scenario
would like to say that in this
stochastic
case,
is
the
best?
scenario which is the best is that
Basically,
we
I
have the
would say
stochastic one, which is the used in this case for the
a batch
application, which
gradient
is used
descent,
for
and then
momentum
like the
indicator
stochastic
for
gradient
particular
descent
closing
we
price
use
in
it
the
for
oscillations.
applications.
And
We
apart
use
from
for
that, we'll
like
be
a
using the stochastic
momentum
indicator
indicator for
for the
particular
random probabilistic
closing price
distribution of the pattern,
in
which
the
is to be
oscillation segment.
analyzed in
So
this
apart
case.
from that, will be used for like a stochastic indicator for the random probability distribution thing of the pattern which you can be analyzing.
Okay, just actually the point is not clear to me. It's not answer which I'm expecting. But the thing is that actually, okay, just tell me the if I ask you, right, you have to create the model, right? So what type of steps you will use, right? How you will start
So basically, if you want to
to
create
make
the
the
simple machine
machine
learning
learning model?
model,
So just
so in
tell
that
me
case,
the
first of
steps
all, you have to
in
get the data
detail,
in the CSV, and then
and
have the
also tell
simple
me the
training set, and then you have to
equivalence,
have the linear
right?
regression,
Okay.
Right?
and then train the model,
Equivalence,
and then
and
test the data, and
accordingly
then finally pull out the
uh,
results. I would like to say in this case from the
some
basic
function,
simple
right?
model
Actually,
on
you
the
are
machine.
suppose you are using an Excel file, and in Excel file there is the data, right? There are some features,
Right.
and you have to firstly read it, load it, and after that you have to do all the steps, right?
Right.
So start one by one.
Okay, what you have, let's say you are loading the data, right? So before I select the model, being a data scientist, what you do,
So in this
firstly
case, we'll
you see
have
the data,
multiple
right?
data
And
scientists
then
which will be
data
there, and then
acquisition,
apart
so
from
you
that,
have, and then once
we'll
you
have
have a
various
data
kinds of
acquired,
things inside that which
and
will be
then
acquired, and
you do
we
for
will try to
data processing thing
put it
firstly.
for the data
Like
processing. And
for
apart
this,
from that,
firstly I would go for that understanding of the data first, so how it looks like how the data is
and we'll pull the data
showing.
from
Like
there and
firstly,
try
I
to
would
use it.
visualize and see what's going on, and then after knowing this, I will do data processing, like preparing feature engineering, like feature extractions, and let's say categorical to the
And we'll try to
numerical
categorize
conversion,
the
and
data
then
and
those
try to
kind of
use
stuff
those
you do,
kind of
like
stuff,
encoding, you do that, and then
and we'll use it in this
after
case for.
pre-processing data, like you have a missing data, those kind of data you treat with the missing data.
And we'll try to recreate the data and then
let's
do
say
the
if you have a
data
continuous
cleansing.
data,
I would like
and
to
then
say in
if
this
your
case,
data
and then
is
the data
normal,
cleansing will actually
we
help
usually
us
do
in
the
this case,
substitute
so that we have
this
to take it
by
from there,
the
and we'll
mean.
try to take it
Sorry, the
and
mean,
use it for data
yes,
cleansing
sorry,
and
mean,
use it in
and
this
then
case.
if it is not a continuous,
So we'll have a continuous
we usually
check
go
in
with
this
the median.
case, I would like to say, for
But
the
in the
data cleansing.
categorical, basically what we usually do, we replace with the mode, or sometimes when you do the encoding and take the average of the encoding thing and then replace with those encoding averages. But practically, like they have been using in the mode, replacing the mode in the categorical sense. And then when you do the pre-processing of the data, like because if you do not have a well-prepared data, that you, no matter what kind of sophisticated model you would use, that can give you the lackluster results.
And then we will
That's
actually
why
load the
we
data set
focus
and
on, like,
understand
it
the
takes
structure by using the
a lot of
statistical
time to
summaries and data
clean
visualization.
up
And
those
then we'll
data.
also use the various
And
kinds
then
of
once you
Python
finish the data
for the
cleaning,
end-to-end
data
project
processing,
analysis and use it
feature
in this way
extraction,
so
those
that the feature
stuff,
extraction can be
then
done, and
you
we'll do the
shortlist the
intent
model
analysis as well
based
as
on
the
the
machine learning
study.
model,
Like
and do the evaluation of
if
some
you
of the
have to
algorithms for
predict like
visualizing the data set in this
values,
case, and
we
try to
use
download
linear
that
regression.
so that we don't have any of the
If you
issues
have
in
to
this case.
classify, let's say you have to choose, because like I said, you have to shortlist algorithms based on the supervised, unsupervised machine learning which you want to apply. And if it is a supervised machine learning, you apply for like if it is a prediction for continuous value, like let's say how much and how many. What would be this kind of values, like a value predictions, those kind of things, you will use linear regressions. And if you have a classification problem, let's say you can apply different kind of models on those based on like if there is what I would say, logistic regression things, two binary classifications, and then if you have a multiple of them, you can treat that, apply the logistic regressions, but you can do